Assalamualaikum warahmatullahi wabarakatuh. Respectfully, the jury of the International Walisongo Science Competition and all the wonderful audience. With the spirit of research and innovation, I try to raise one simple thing, that math is not just numbers, but also a solution for a better life. On this occasion, I will be present application of differential equation SEIR model in simulation of malaria disease spread in Mimika Regency. First, introduce, my name is SELLA ALAWIYAH FAILANI, representing from Walisongo State Islamic University Semarang, from study program Mathematics Education. Malaria is an acute or chronic disease caused by protozoa of the genus Plasmodium with manifestation in the form of fever, anemia, and enlarged spleen. Meanwhile, according to other experts, malaria is an acute or chronic infectious disease caused by Plasmodium infection that attack erythrocytes and is characterized by the discovery of asexual form in the blood, with symptoms of fever, chills, anemia, and enlarged spleen. Mimika district is categorized as the highest malaria endemic area in Indonesia, especially in Papua. The average incidence is close to 200 cases per thousand population per year. In 2017, the population of Mimika contracted malaria in 92,342 cases. This number places Mimika as the highest supporting district for malaria at 29.12% of total number of malaria cases in Indonesia. To determine the level of spread of malaria can be done using a mathematical model. A mathematical model is an appropriate change in equation to describe change in variables as a step to describe a system. In this case, it can be modeled through the SEIR susceptible, exposed, infected, and recovered model. The SEIR model divides the human population into four variables, namely, humans who are potentially infected with the virus is susceptible, humans who show symptoms of the being infected with the virus is exposed, humans who have been infected with the virus is infected, and humans who have recovered in recovered. Here is the equation. The relationship between these four groups can be represented in figure. The susceptible population becomes the exposed population at the rate beta. The exposed population becomes the infected population at the rate epsilon. Then, the infected population becomes the recovered population at the rate c. Basic reproduction numbers. The basic reproduction numbers is a number for indicates the number of susceptible individuals that can suffer from the disease caused by one infected individual. The basic reproduction number is obtained by determining the eigenvalues and the Jacobian matrix of a system of equations calculated and the disease-free equilibrium point. The basic reproduction numbers is denoted by R0. There are three conditions that will arise, namely, if R0 less than 1, then the disease will disappear. If R0 is 1, then disease will persist. If R0 more than 1, the disease will increase to an outbreak. Establishment of the SEIR model of malaria disease spread. In this case, there are several assumptions used to model the spread of malaria. Namely, there are births and deaths in a population. The death process can occur in classes SEIR. Every individual born will be susceptible. Disease can be cured. Individuals who have recovered have a temporary immune system. All people have an equal chance of being infected. Treatment is carried out on the exposed individual. This picture is representing from SEIR model of malaria disease spread. This picture can also be interpreted into a mathematical model in the form of a system of differential equation. Here is the equation. And here is variable and description. Next, we will analyze of the SEIR model of malaria disease spread. First, the equilibrium point. The equilibrium point occurs when the derivative of S with respect to t. Point, the derivative of E with respect to t. Point, the derivative of I with respect to t. And last, the derivative of R with respect to t, all in 0. Secondly, we will analyze basic reproduction numbers. The basic reproduction numbers of malaria is obtained by determining the eigenvalues of the Jacobian matrix of a system of equations calculated at the disease-free equilibrium point. This is the formula for R0. Next, model simulation. Assumed variables and value as listed in the table. Simulation using parameter values 1 and 2 as written in the table. If the values of parameter 1 and parameter 2 are substituted into the R0 formula, the value of R0 is 0.095 more than 1 and the value of R0 is 0.562 more than 1 are obtained, which means that a person infected with malaria does not cause other people to get malaria. And this is the picture simulation of the SEIR model for parameter 1 and parameter 2. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh. Have a good day.